I want you to imagine something. Let's go way back, about 2,500 years ago, to ancient Greece. There are no microscopes, no fancy labs, no particle accelerators, nothing but pure brain power. And yet, one thinker came up with an idea so powerful, so ahead of its time, that it now underpins pretty much all of modern science. Today, we're going to talk about the man who first imagined atoms.
All right, so here's our game plan. We're going to start with a huge, fundamental question about reality itself. Then we'll dive into the radical new idea that answered it. We'll break down the two key components, atoms and the void, see how they build a whole universe without a grand design, and finally, trace the incredible journey of this idea right up today. So let's start at the beginning, with the problem that kicked this whole thing off. A question every curious mind has probably asked at some point. No, really, think about it. If you take anything, a rock, a plant, even your own hand, and you could just keep cutting it into smaller and smaller pieces, what happens? Do you just keep cutting forever? Or do you eventually hit something so fundamental that you just can't cut it anymore? Now, before our story really gets going, the answers people had were, well, all over the place. Some philosophers were pretty sure everything was just made of one basic thing, like water or maybe fire. Others argued that actually all the change and division we see is just an illusion, that reality is really just one big unchanging block. And of course, there was always the go-to answer: the gods made it all happen. So, into this world of ideas steps a philosopher named Leucippus. And he comes forward with an answer that was so simple and so completely different from everything else, it would eventually change how we see the world. And this is where Leucippus just sliced right through all the noise. He said, look, forget all that. Everything, and I mean everything, is made of just two simple things: tiny, indivisible particles and the empty space they move around in. That's it. No magic, no gods pulling the strings, just particles and emptiness. I mean, what an incredibly bold and modern idea for its time. Okay, so to really get our heads around his theory, we need to break down exactly what he meant by atoms and the void. He called these particles atomos. In Greek, that literally means uncuttable. For Leucippus, this was the end of the road. You couldn't split an atom. It was the absolute fundamental building block of reality. And these atoms had some very specific qualities. They've been around forever, and you can never destroy them. They're perfectly solid, no empty bits inside. And get this, he thought there were an infinite number of them, in an infinite variety of shapes and sizes. Some might be round, others jagged, some could even have little hooks. And the most important part? They are always moving. But wait a minute. If the whole universe was just crammed full of these solid atoms packed together, nothing could ever move, right? Nothing could change. For this whole system to work, it needed a stage for all the action to happen on. And that stage was the void. To us, the idea of empty space seems pretty obvious. But back then, this was a huge deal. The idea of a true vacuum, of actual nothingness, was just as radical as the atom itself. A lot of other famous thinkers just couldn't accept it. They insisted nothing can't exist. But Leucippus said it had to exist. Otherwise, motion is impossible. The easiest way to picture it is with Legos. The atoms are like a gazillion Lego bricks. The void is the empty room you're building in. You need that empty space to move the bricks around, to pick them up, and to snap them together. Without the room, all you've got is a solid, useless block of plastic. So, we've got the ingredients, we've got atoms, and we've got the void. But how do you get from a bunch of tiny particles zipping around to a whole universe? This is where Leucippus's theory gets really amazing, because it explains how everything can exist without needing a creator to put it all together. This quote right here is the heart of it all. For Leucippus, the universe wasn't just random chaos, but it wasn't being guided by some divine will either. It was all governed by necessity, which is really just an old-school way of saying cause and effect. The physical properties of the atoms themselves determine how they're going to interact. It's just physics. And here's how he pictured it happening. You have all these atoms zipping through the void. Eventually, they're going to crash into each other. Because of all their different shapes, some will stick or hook together, while others bounce off. Over vast amounts of time, these collisions start to create huge, swirling whirlpools of atoms. These clusters just get bigger and bigger, eventually forming massive bodies like our planet, the sun, and all the stars. All of it happening naturally, just because of how atoms move and interact. Okay, so let's step back and just appreciate how mind-blowing this idea was. Leucippus wasn't just making a lucky guess. He was laying down the foundation for a totally new way of understanding the entire cosmos. But, this brilliant idea didn't have an easy ride. After Leucippus proposed it, other super influential philosophers, especially Aristotle, just couldn't get on board with the whole empty space thing. And because Aristotle was so respected, the theory of atoms was pretty much dismissed and forgotten for almost 2,000 years. It wasn't until the scientific revolution in the 1600s that scientists rediscovered it, dusted it off, and realized, wait a minute, this guy was onto something. And now, of course, it's the bedrock of modern science. When you boil it all down, the greatest gift Leucippus gave us wasn't just the atom. It was the revolutionary idea that the universe is a system that we can actually understand, that it works according to consistent physical laws that we can figure out just by using reason. He basically handed us the user's manual for science. And that manual leaves us with this one final, massive question that we are still trying to answer today. If everything, the stars, the Earth, our own bodies, our brains, if it's all just a temporary arrangement of atoms moving by unbreakable laws, then what is consciousness? What is a thought? An emotion? It's pretty incredible, isn't it? An ancient idea posing the most modern question of all.